Thank you so much, everybody, for joining me. This is really exciting for me. I've been, very active this year in the frontend community, as always, in the past few years. But giving talks, supporting other folks, giving internal talks. So it's really cool to be able to do something that's also being carried outside externally to ThoughtWorks. So thank you so much for making that happen. So today I'll talk about Kelda, which is a thing that I made. And I have not given this talk for about 5 months. So if I'm a little rusty, I apologize in advance. I was working very hard on Kelda earlier this year, and then life happens and work happens, and I got sidetracked. So this is actually a great opportunity for me to get excited about this silly, stupid project again. So in the course of this presentation, you will see a lot of pictures of garden gnomes. This is because when I originally did the internal presentation, there was a lot of sort of copyrighted imagery that I cannot use for the external presentation. So now here you have some garden gnomes for your enjoyment. So let's talk about Kelda. Well, actually, I just wanted to, to give you a little bit more color about me before I get started. So my name is Rufus. I'm a developer at ThoughtWorks. I'm sometimes a tech lead. I co-founded the ThoughtWorks frontend community because it's something that I care about, as well as the other folks in the community. We've got almost 1,000 people now who are active every day talking about these issues. And one point of pride for us is that we oftentimes are really on the cutting edge of this stuff. And we have in the past actually preempted sort of more broadly the industry in terms of the patterns and the techniques that we've been talking about. So for example, micro frontends is a fun one, something that we've talked about extensively for many years at ThoughtWorks since the community got started, and it really became sort of a term that got thrown around a lot in the last year or so. So that's a cool thing about the community. I'm currently based in New York, but I've worked for ThoughtWorks in a number of different places, and I'm actually relocating to Berlin early next year. So if you're around, come say hi, please connect, and I'd love to hear from you. Okay, so let's talk about the word Kelda first of all. I am a huge Terry Pratchett fan. I love his books, and there's one book in particular, actually a series of books, which starts with The We Free Men, in which there is a race of tiny pixie-like, gnome-like creatures, which live in an interesting society where women are very rare. They're very rarely born, and so it becomes a matriarchal society. And in this story, a human girl, Tiffany, becomes the matriarch of such a clan. And the name of that matriarch position is called Kelda. And so the first thing she does with her power is to make them do chores. And so, of course, I thought, for a JavaScript library that spawns worker processes to do work, Kelda would be a fitting name. So as I mentioned previously, in the original 1.0 version of this presentation, I had a lot of the sort of copyrighted Terry Pratchett illustrations. So instead, you'll have to make do with this approximation thereof. So we'll have a lot of garden gnomes to look at. And I figured it could be fun. So if you're unfamiliar with the works of Terry Pratchett, but you're in Germany, you can think of them as Einzelmännchen. So up front, before we get into the specifics of Kelda, my hope with this presentation is that you come away thinking, oh, that was interesting, but I'm never going to use it. So over the course of this presentation, I hope to share with you some things that I learned, that I enjoyed learning, that I thought were interesting on the road to building, or the road along as I was building Kelda. But at the same time, there isn't really a good use case for it, I don't think. And in addition, Kelda cannot be as good as I would like it to be, ultimately because of limitations in the browser. So we'll get to that. And if you ever do find yourself wanting to reach for a thread pool in the browser, you should probably stop and think really carefully about it. There are almost always better solutions. Change the UX. If you find yourself needing it, you should probably be building a different thing. It might be a different technical design that you can use to not need such a sort of nuclear performance optimization in the browser. So with that out of the way, let's talk about the fun stuff. So Kelda is a JavaScript library. It lets you do work outside the main thread. So as many of you, I'm sure, will know, JavaScript is a single threaded language, which means that if you ever need to do multiple things at the same time, you literally can't. right? So the language makes heavy use of asynchronicity as a first class premise. And so, you have an event loop, and you can schedule events and event handlers that allow you to get a facsimile of sort of parallelism when in fact you don't really have it. And that's fine for most sort of UI browser-based use cases, because you just don't do that much heavy computation in the browser, because why would you? But if you ever do end up in such a situation, even asynchronicity can't really help you, because eventually you'll just have to reserve a big chunk of the runtime in order to do that big calculation. And during that big calculation, the world stops. So there are some ways to do some threading in the browser through the web worker API. This is an API that's been around for a long time. I'm sure many of you have played around with it in the past. I'd be curious to hear in the Q&A later what your, I guess, real world use cases have been for it. But the web worker API lets you create worker processes that act as separate threads and let you unclutter the main thread. Kelda sits on top of this and sort of takes the nastiness of that API away for you. And it sort of acts as a configurably sized thread pool. So all you have to tell it is how many threads you want to have available, and Kelda will spawn and kill those processes for you. Kelda is still experimental to the degree that when I did the first version of this talk about half a year ago, I actually found a major bug in preparing for it and preparing the demos for it. And so that's why it's still at a 1.5.x version as opposed to, sorry, a 0.5.x version as opposed to 1.0. So still playing around with it. Love to, if you would like to get your hands on it, I'd love to hear your feedback from what kind of issues you run into with it. Okay, so in the previous version of this talk, I talked for a really, really long time before getting into the interesting bits. And so I think I'll just start us off today with a demo. So hopefully you can see this. It's just a little test app that I built. It ships with the Kelda repo, so you can test out whatever it is you're doing in there. And I just want to demonstrate the premise of why web workers are useful and the value that Kelda can give by sitting on top of them. So I'm just going to demonstrate, I guess, the problem that you can run into if you have a single-threaded language and you have to do a large calculation. So I'm just going to start this timer, and you can see the timer updates every second. And the long calculation that I want to do is going to be an unoptimized Fibonacci sequence algorithm, because I'm bad at computer science, so I wrote it the crappy way. And so because of that, it's going to take a really long time. And so I'm going to calculate the 44th Fibonacci number, and I'm going to press start. And if I can just draw your attention to the number, it's frozen now. And that's because the main thread cannot update the UI while that calculation is being resolved. So that really sucks. So if you ever find yourself in that situation, and you see now the calculation is back and the timer is able to resume. So if you ever find yourself in that situation, it's nice to just be able to avoid that by not being on the main thread. So here is going to be a quick example of the, I guess, the difference that Kelda can make. So I'm going to do the same calculation. I'll calculate the 44th Fibonacci number, and I'll do it from Kelda. And you can see that as Kelda is working, the number can continue to increase. And that's because that calculation is resolving in a separate thread, and then eventually it'll come back and report its result. There we have it. So hopefully that has piqued your interest enough to keep listening to me as I return to my slides. So a brief segue into web workers. They are a first-class browser API, so it's something that's the sort of the spec has added on top of the JavaScript runtime, something that exists only in the browser. Although Node and now Dino are also making use of workers. Dino in particular is trying to go for a lot of parity with the the known browser runtimes that we're used to, so that's pretty cool. And so communication between these worker threads and the main thread happens via post message. Again, something that's pretty standard that we're used to from working in a browser. They can also communicate with each other via a broadcast channel object. I've never had cause to try that, but that's really interesting. And basically any data that passes via post message between the main thread and the worker thread is passed through the structured clone algorithm. So let's keep that in our mind because that algorithm is really important and is really the the bane of any kind of threading that you want to do in the browser. Web workers are old. They're really established. The first draft of the spec was introduced in 2009. And if you have any kind of vaguely modern browser, you should be able to run web workers. So there shouldn't be any fear of support, of lack of support. However, if you ever run Kelda in a browser environment that does not have web workers for some reason, it will just fall back to the main thread. So then your calculation is just not optimized, but will still work. So this is what it looks like to make a worker. You create a new worker object and you tell it the script that it'll then try to load. And these scripts that you give to workers are interesting. They sort of are a bit idiosyncratic in that they have their own, I guess, sort of runtime environment. Some of the stuff that you have available in the main thread, you won't have access to in workers. For example, you can't change the DOM from worker threads, but there's also other stuff that exists only in worker threads. So for example, there's this self object that you can use to set up message handling. That of course doesn't exist in the main thread. This refers to the worker itself. And you can see this is how you can set up simple messaging between the main thread and this worker thread. And this is really kind of at base how Kelda works. It spawns up these worker processes and it sends messages back and forth that start work and then report the success or failure of work. Kelda, by contrast, takes some of that stuff away from you, so you don't have to sort of deal with I guess the less enjoyable parts of the web worker API. For example, it is really difficult to test web workers. I was very surprised by this when I first started working with it because it's been around for so long and it's so useful and so interesting. I couldn't find a good mock web worker at least in my research, so I ended up having to write one myself. So that kind of sucks. And so if you have Kelda, of course, you can just ignore that. Don't have to worry about that. At sort of the best case scenario, when you use Kelda, is it just looks like this. You create a Kelda, and then you tell it you order work, and you give it a function to do. And then the Einzelmännchen go ahead and do the function and then come back to you. And Kelda gives you a promise. So you have those nice first-class asynchronous constructs that you know and love from just regular JavaScript. So Kelda is good, of course, at managing heavy computation for you. If for some reason you want to do that, and I will continue to emphasize that that's not a good idea. And that's really just the strength of the web worker API itself. Where I guess Kelda's more unique value proposition is that it's good at managing multiple workers for you at once. I've seen one or two other attempts at providing a web worker abstraction, but they're not really that nice because oftentimes, or at least I haven't seen one that gives you a managed thread pool solution. So you're still like they take away the cruft of having to create and kill web workers, but you still then have multiple workers potentially floating around. And Kelda can just do that for you, right? You just tell it how many you want and it just deals with all that for you. So it manages the life cycle of workers for you and so on, right? And Kelda itself also only works really with, or is particularly good, I should say, at working with simple return types. And this is because of limitations, both performance and otherwise, of the structured clone algorithm. So if the arguments and the return values that you're sending back and forth from the main thread to the worker thread are small and are of certain workable data types, then everything is great. But Kelda cannot, of course, support browsers without workers, although as I mentioned to you, it won't just break. It cannot pass references from the main thread to worker threads. This is really important. We'll get more into what that means later on, because this is kind of a doozy. And finally, Kelda can't solve your design problems for you. So if you're having serious performance problems in your JavaScript, most likely it's a problem with the UX that you're building or the technical design that you have, and just throwing a thread pool at it is not the right solution. And I say that in the full knowledge that I did this exact thing last year on a project. So just giving you a heads up. So understanding a little bit about what Kelda is, how does it work? Basically like this. Oops, excuse me. So you can configure Kelda to tell it how many threads you want in the thread pool. So here we're saying 4. I have somebody on my GitHub telling me, I was very convinced that thread pool depth should be called thread pool size. So who knows, maybe that'll be part of the API that changes. But this is basically how it works. You order work, that work goes into a job queue, and then jobs of work are popped from that queue based on the availability of threads in the thread pool, which of course is bounded at the top by the maximum thread pool depth. And then whenever a thread becomes idle, pop a job from the queue and create a worker for it and do the job. So I also just wanted to give a bit more technical detail on how that works. So you can think of it really as this, I guess, control flow of really 2 trousers of time, as Terry Pratchett would say. So there are 2 options for how this calculation can go. First of all, at the top level, we check if workers are available. If they're not, then we just call the work function right there in the main thread, take the performance hit and return the result, return the promise of the result. But if they are, what we do is in order to get a worker that contains that work that you're trying to do, you have to build that worker dynamically. So there's some like standard worker initialization code that is inside of Kelda, and then we try to sort of shoehorn your work into it. The simplest way that that works is by simply stringifying the work function. This is a thing that you can do with JavaScript that's really fun and interesting, but it's also really weird. And I'm not sure if it's good or not. So let me just demonstrate to you what that means exactly. So hopefully, can you see that okay? Is that too small? I hope you can see that. So I'm just going to quickly make a function here, and I'll call that hello name. And this will just log out the name. Okay. And so if you were to give Kelda this work function, and actually, this is not a good, this is actually, now that I see this, is actually a terrible example of a work function because this doesn't return anything. So this would simply log out when it's called. This would simply log out the name in the worker process and be useless. But this just as a demonstration of how stringifying a function works. So if I make a constant here, where I'll just say stringified will be hello to string. And if I look at what that is, you can actually see that it has gotten the entire definition of that function as a string. This is a really interesting thing that exists in JavaScript. So you can do a lot with that. So of course, if you evaluate this, you can get the function object back. So at a high level, the way that could work is I'm just going to use a let here in case I make a mistake. So I'll just say let f. And then I'll use the function constructor, which is a way of evaluating a function body. And I'll just say return and then I'll have my stringified function here. And I'll just add a semicolon because I like semicolons. And then if I call that, and this should give me back function object. And if I call that function object with a name, then it logs that Janajad. So hopefully that sort of gives you an idea of how we can take like a real JavaScript function object, stringify it, shoehorn it into a worker thread, and then sort of spin up that worker. Needless to say, you should make sure that whatever is in your function is safe to be evaluated. So you get some protection, of course, simply by being inside of a worker thread, but still, you don't want any dynamic user-generated content inside of the work that you pass to Kelda. Okay, so once we have the worker script, which consists partially of the generic Kelda worker recipe plus your work. We then create a blob object out of that long string. And then we can create an object URL for that blob, which is a way that the browser can create a dynamic sort of local URL for some data. So now the browser has sort of a random, it's like a hash URL that you can visit in order to get back the worker script. And then we can simply instantiate a new worker and point it at that object URL. And then it starts its lifecycle. And once it's ready, Kelda then sends the Kelda start message, and it'll start evaluating that work function. When it's done, it'll send back the Kelda done signal with the return value if there is any, and then the promise resolves. So a big question that I had when I found myself wanting to use web workers was, why didn't this already exist? It seems like a really obvious thing to exist. It's a really convenient thing to exist. Why wasn't there a managed thread pool for dealing more easily or enjoyably with web workers? Because it sucks, that's why. So I think that probably the reason why nobody has done this before is because the web worker API is really limited and it's not enjoyable to work with. So what I've shown you so far is only really the simplest and best case scenario. So where you take a function and give that function to Kelda, that is like the ideal scenario, right? Because you don't have to do anything else. You can just give a function and get back a value. That only works in the simplest cases, and it only works in the case where the body of your function does not reference any value that is not defined inside of it, right? Because that value doesn't exist in the runtime of the worker. So that is kind of a bummer. So because of that, if you ever want to, like modularize your code or anything, this is not an approach that is really good, because suddenly you can't reference module imports, you can't reference third-party libraries, you can't reference anything that isn't itself defined inside of the context of the work function. So this was a bummer, and I spent a long time thinking about this and trying to find ways to get around it, and ultimately decided that probably like many other people who have tried before me, this was not a problem that was going to be solved easily or trivially, and sort of threw up my hands. And so instead, I sort of went in a different direction with creating a workaround. There are also other limitations, like you can't pass certain data types between the main thread and the worker threads. Functions, for example, you can't pass around. And so there are just some really significant problems with I guess the best case scenario that like stops you from doing anything of any value. So because of that, I came up with the concept of remote work modules. And so these are essentially like their own script that you can then bundle. So you get the entire world of what that script needs in sort of one place. And you can then sort of point Kelda at that script, right? So this is inconvenient, right? It means that you need a separate build and bundling process for those work scripts. And it's just not as nice as just passing it a function and getting back a value. But it's still pretty good, because you still end up getting a lot of bang for your buck just from having the managed thread pool sitting on top of your normal sort of web worker flow. If you ever were to use web workers, you would in any case need to have separate scripts for them, because that's how web workers work, right? Web workers want a URL that you give to them so that they can initialize themselves. So this is just, unfortunately, like I guess a regression closer from the original design that I wanted to, I guess, to where we ended up. I guess to make this just a little bit more visual, here we have the two threads, we've got the main thread and the worker thread. They send messages backwards and forwards via post message. Every time the data goes through a post message, you apply the structured clone algorithm. And that algorithm is restricted in the data types that it can copy, right? So for example, you can't clone a function, it's not a thing. However, you can get around it, as I mentioned, by stringifying simple functions. But since the structured clone can't recursively stringify references, or since we can't recursively stringify references, there isn't really a way to to like have module imports and other like basically like reference any things that are defined outside of the body of the function. So this was really disappointing, but I've sort of made my peace with it, I sort of spent more time, I guess, looking in detail at how the workaround could work. And so let's talk a little bit about remote work modules. Remote work modules are like, I guess, the equivalent of this sort of dirty and broken GNOME, where originally you had a really good idea and then it just turned out to be not that workable, and then it just ends up sort of sad and broken, but it's still kind of better than nothing. So that's what remote work modules are to me, at least emotionally. But what I mean by remote work module is basically any JavaScript script that when you eval it, you get back an object that can act as a module, right? And by that I mean you have the keys that correlate to the name of the exports of that module, and then the values are the actual exports. You'll need a separate build and bundling process. So the build and bundling process that I use for my remote work modules uses Webpack, and you actually have to do quite a bit of a configuration that you apply in order to allow you to get the production optimizations of Webpack, but still retain the return value of the overall script. I guess I'll try to explain that a little bit more in a second. But once you have that, you host that on your server, that module script on your server, and you pass the URL to Kelda, it pulls it and creates your workers for you. You still get a bunch of benefit from using Kelda, because Kelda can cache those scripts internally, and it can sort of do a bunch of other stuff that I thought was cute and interesting, like it can do eager versus lazy loading and stuff like that. So you have just a bit more control over when and how your workers get created. So this is what a remote work module might look like. So at the top level, you might have two exports, a named one called myExport, which is a function that takes 2 arguments and returns something. And then you might have a default export, takes an argument and returns something. And importantly, your bundling process needs to take that, your build and bundling process, I should say, needs to take that, resolve all of the references correctly as a bundler should, and give you back something, some gobbledygook JavaScript that ideally is, of course, optimized for production, but still returns you an object when you evaluate it. And by default, at least Webpack optimizes the return value away. Right? So it is a side effecty eval for at least the default way that Webpack comes out of the box, at least 5 months ago. So I had to apply some. I had to do some digging to figure out how to stop Webpack from doing that. And so you have to do some modifications to the Cursor plugin to stop it from doing that, to still give you back the module object when you eval the bundled and built script. But once you have that, you can then point your Kelda to your script, and you can say, hey, here's my remote work module. And by default, it will assume that your desired work sits at the default export, and it'll execute that. But of course, you can also configure it and tell it what the export name is. So one potentially interesting thing is that you could have all of your work inside of a single work module. So you only have a single separate build and bundle process, and then you could simply create workers that look at different exports from that module. So let me go back to the demo. So I've talked a little bit more about how Kelda works. So here, I just want to draw your attention again to the timer. And so I showed you earlier what it looks like when you run Kelda from a self-contained work function. So in that case, I basically just redefined the entire lazy Fibonacci algorithm inside of its own function and passed that to Kelda. And so then these other options are ways of experimenting with remote work modules. So the first one that I'll show you is this one. Let's just do a quick one. Let's just do, I don't know, 38. No, actually, that was too fast. One interesting thing, so again, the timer continues here. One interesting thing is that when I first started working on Kelda, when I first built this test app, occasionally in Chrome, it would still skip numbers while the worker was doing its thing. And then a new version of Chrome came out and that stopped. So I think they did something, but I'm not sure what. I'm grateful for it regardless of what it is. So what I did just there is I calculated this result, the 42nd Fibonacci number from a remote work module, and basically Kelda loaded that eagerly, right? So it loaded the remote work module as soon as the work was started and before you actually decided to execute it. And it also cached it. So what Kelda can do is it can give you back a work ID for the script that you load, and then you can just call that ID multiple times or can give it to Kelda, and it doesn't have to do the fetch for the script every time. And then one other thing to point out is, of course, you can also do lazy loading. So then the fetch would only happen the first time that you actually execute work. And then one other thing to point out is that you can also do various different export names. In this case, the default and the inefficient Fibonacci, the default and the named export both point to the same function. But of course, if you give it an invalid name, you get an error as you would expect. And so this is just the promise rejecting and me adding the alert as a catch on the promise. Cool. So having seen and understood that, when do I need Kelda? Almost never. I really mean this. It's quite difficult to need this. So why might one want to do some threading in the browser? Well, generally it's because of performance, right? Like something is happening, it's taking up a bunch of cycles and you want to put it somewhere else. The correct place to put that somewhere else is not in JavaScript, like not in your UI. Use a BFF or put it on your backend or something. But sometimes, for whatever reason, and oftentimes this is not technical reasons, oftentimes it might be organizational constraints. Your team might not have control over anything but the UI, blah, blah, blah. Sometimes that's not possible. And so then you have to do your best in optimizing what you have. But JavaScript performance issues, I think, are often design problems, either UX or technical design problems, often the result of suboptimal UX requirements. So then it's sort of up to you to work with the business to get around it, maybe come up with a better solution. And because of that, you can also solve the problems in a number of different ways before needing a thread pool. So having made that claim, let's look at a specific example. So let's think of a table component. If you do any amount of UI development, you'll find yourself making tables over and over and over again. A lot of our applications are basically just, fancy ways of displaying databases. And let's think of a table component where the spec, for whatever reason, is this has to support a very large number of rows. Okay, this is a silly thing to exist. Of course, this is not good design, but this is actually a use case that I had last year on a project where we were under a lot of pressure to deliver something very quickly. And the client was dead set against any kind of pagination in how we tabularized their data. So that was really important to them for some reason. And we were fighting a million other battles trying to keep the ship going forwards and making sure that they got the quality that they were looking for. And so this was just a battle that we couldn't win at that time. And so we had to support a lot of data in the UI. I'm going to use the language of React now. And that's just because I think the two words reconciliation and rendering are really useful because they're very clear. But the same logic applies to any other framework or even just vanilla, depending on how you're building your UI. And I hope you can sort of see that I'm not specifically talking about React here. So the two performance bottlenecks that I want to point out when you have something like this, right, where you have like a component that's very large, that's like rendering a lot of child components, and that is accordingly going to have a lot of data that needs to feed all of those child components. The two relevant bottlenecks are reconciliation, which is when you figure out what the next state should be, right? So you have your current table, new row data comes in. Okay, now you need to figure out, here is the big old array of rows. Here is going to be the new array of rows, and we need to figure out what is the next state going to be. And rendering, right, which is when you actually take what has been reconciled, you figure out what the next state should be, and you sort of flush those changes into the DOM, into the document. Both of those can be really slow. Let's just visualize that really quick. So let's say we have two Again, this is sort of the language of React, but it applies regardless. I stole these excellent illustrations from Christopher Chateau. He made these in, I believe it was about 7 years ago, back when React was shiny and new, to help folks understand how it was working. And so in this case, you can see that when something happens, in this case, so this set state call happens. So in our table example, let's imagine the data, a new data object arrives from an API. We now need to figure out, okay, what's the next state going to be? And then we need to take that information and we need to actually flush it to the DOM. So then we render the new set of rows. So applying that to the table example, almost certainly your API does not speak UI, right? It doesn't speak table. Again, that could be a design thing, right? Maybe you have a BFF, maybe you have a GraphQL client that does this for you. But in the case where this is a problem, your API data needs to be transformed from something that the domain understands or that the API understands to something that the table understands, right? So here we have some process that takes an array of API data and gives you back an array of row data. And that transformation, we'll just call it row building, right? And so this, the performance of this is directly proportional to the n that you have, right? The more rows you have, the longer it's going to take. That's simple. That's the reconciliation step, right? Because that's part, building those new set of rows is part of figuring out what the next step is going to be. And then finally, or next, I should say, in the rendering step, you're again limited by your n, because now you have to insert one row for every row data object that you've calculated. So in both cases, both these steps are bounded, or are directly proportional to the n that you have. So when you get a very large data set, this can get really slow. So you know, there are a number of different ways of approaching this before you would ever resort to something as nuclear as a thread pool. And some of them I'm going to talk in detail about because I think they're interesting and maybe they'll help somebody. And you know, I like to share these things, so I'll dive a little bit more detail into those. So one strategy is virtualizing table scroll. This is a rendering optimization. We'll talk about that in more detail in a second. We could lazily build row data, so the row data actually builds as you scroll. And then as a last resort, you might end up resorting to Kelda. However, first of all, change the UX. You know, make the table scroll, or sorry, make the table paginated. You know, make it so that for whatever reason, you know, there's no way to show the entire data set at any one time. You know, limit it to a certain number of rows. That is the correct solution. However, that can get difficult in certain circumstances. I actually just remembered one of the arguments that we had against pagination was that we were also having to support real-time updates. So, you know, we built out a nice little WebSocket solution that was sending updated data. So it was changing rows, it was adding rows and removing rows. And so the entire, I guess, data set could change quite a lot over time dynamically, you know, as we went along. And so when you have a pagination approach, it can be quite difficult to keep track of what does it even mean to be on the same page as before a change, because the entire set of data is just changed. So that was one of the reasons why we sort of leaned away from that approach as well. So let's do some more demos. And I'd like to show you what I think it actually takes to get to a use case for Kelda. So I just switched over the tab to the next demo that I have for you. Hopefully you can see that okay. Let me know if that's too small. I can always increase the zoom level. Okay, and yeah, you know what, I will actually do that. I've got a couple of different tables on the left here. And so I'll start with just a basic HTML table, right? So I have an API. I'll just load 1,000 rows from that batch. And now I've got a fully populated table. This API, just a fun fact, it's built in Dino. One of our colleagues from Australia, who is extremely prominent in the front-end community, is super involved in open source and has been closely involved with with the development of Dino, which is really exciting. So I got some good first-class support from him in sort of building Kelda and preparing this talk. So yeah, shout out to him. So we have our table here now, and as you can see, the table also has to respond to user interaction, which is really important. Right? So we have some checking ability, and we've got some selecting ability. Doesn't really matter. It's probably confusing that these rows can do both, but whatever. It's just an example. And the important thing is, I know you can't hear me click, but I'll just give you a feeling for it by saying the word click. When I click, 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 click. You can see that it's pretty responsive still at 1,000 rows, right? Like it doesn't really feel like there's a big lag time. The perceived performance is pretty good. But when I increase the number of rows, click, click, you can see that it starts getting laggy, click. And this is because of those two operations, the row building and the insertion of additional of the new rows that I mentioned earlier. Right? Both are bounded. Well, both are proportional to 5,000 in this case, to the number of rows. That's just a plain HTML table though, right? So that's simply under the hood, we've simply got an HTML table. There's nothing fancy about it. Every time new state comes in, React, in this case, it's React, I'm using React, is going to be reinserting the entire number of rows here. So that's not good. So one way to make this more performant, if we wanted to, would be to use a virtualized table. So in this particular case, I'm using a library called React Virtualized. It's a bit old now. Probably shouldn't use it if you're starting from scratch. I just use it because I just used it. I was familiar with it. There's I think React Window, which I think is by the same author. Might be misremembering the name though. There are more modern alternatives available for you. And you can see that now when I do click, 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 it's really fast again. And the reason this is fast is because virtualization removes the bottleneck for rendering. So we're still building 5,000 rows, but we're only inserting as many as are in the view at a time. So as I scroll, this table is inserting more rows just above and below, like out of sight, just in time for me to see them. Right? So sometimes if you scroll super fast, you might see it flash. That's because you're actually getting ahead of the table. So this is, you could think of it as lazy rendering in a way, because we're only rendering as we need to see, as we need to have the rows available for seeing. This is really good. This is a very nice sort of solution for this, and probably this is what you'll only ever need. However, in the case that you have more of a complex row builder that takes longer, you might also run into the reconciliation bottleneck. So at this point, I'm just going to very quickly jump over to the code. Please don't get, like we don't have to understand any of this. I just want to draw your attention to this piece here. So this is the function that I'm using to build the row objects from the API objects. The important thing to note is that the build rows function takes an array of users and returns an array of rows. And up until now, the complexity of that has been O of n, which means that we just do one sort of loop through the entirety of the row data set, or in this case, the user data set for the row building operation. But because we wanted to test our system under more high pressure, we could also change that to O of n squared, which is going to be very slow. I should definitely have reduced the number of users there. Let me actually move that down to, actually let's do 2,000 first. It can actually happen that you end up freezing your UI thread completely, and then your tab may crash. I once created a bug a few years ago. I was actually working in Germany, where I exponentially increased the number of rows in a table every time you did something. Every time you clicked on something. It was funny while it lasted. We definitely, like, at some point you just crash the tab. So you can see that now, click, click. The virtualized table is now struggling with this because the rendering optimization isn't helping, right? Because now we're spending a lot of time in the reconciliation step. So again, to just visualize this, you can see I just did, this is obviously completely contrived, right? Up until now, each of these users in the table has had no best friend, so they've just been lonely. But now that we've increased the complexity to O of n squared, we're actually going to be generating a random best friend by going through the entire data set again and finding somebody else who's going to be their best friend. Obviously, this is silly. I said that I wasn't good at computer science, but if you end up in the situation where your row builder is more complex or takes more time, suddenly this approach doesn't really work for you anymore. You can see it's slow. So then, as a next step, we can attempt to use what I call a lazy virtualized table. So now it's not just lazily rendering, it's actually lazily reconciling as well. So click, 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 click. You can see it's once again nice and snappy, and that's because not only are we sort of lazily inserting the rows as we scroll, we're also lazily calculating their row data as we go. So we've made instead of calculating the whole like row data set up front, we're just passing the row builder as a function to the table itself, and it'll dynamically generate the data for each row as you scroll. So you can get a whole lot done with that, and that's pretty cool. So let's just bump this up to, I don't know, let's say 5,000 again. Click, click, click. There's like a very little amount of lag, but it's honestly, it feels pretty snappy. And I, like as a user of this, I wouldn't really bat an eyelid. I wouldn't bat an eyelid. I've been speaking more German recently in preparation for coming back to Germany, and it's affecting my English. So struggles. So this is pretty good. I think with this, you can pretty much get all the bang that you would ever need for your buck, and you're probably going to be good. However, if for some reason you have multiple tables on your page that all have the same requirement, click, click, you start to get slow again. And now our, let's go to 7,000. Our requirement at the client that I was on last year was at around 10,000. Click, click. Let's go to 10,000. Click, click, click. So you see the lag is starting to come back. Let's go to 4, why not? Click, click, click. So now that lag is being produced just by the fact that we have 10,000 rows that are being processed at O of n squared 4 times in succession in the main thread. That's it. So at that point, you sort of reach the limit of what you can do in the main thread. There isn't really much more that you can do here. Now, if you get to this point, then you might have a use case for Kelda. So there's quite a lot that you have to do to have to get to this point. Actually, I didn't even tell you the reason why we got to this point. It's a very interesting story. Maybe you'll be able to relate. We were under a lot of pressure to deliver a really important product. We were going to be helping the clients advance their business. Actually, one of their C-level executives called us and brought us in to rescue their project. We landed a team of mostly senior people, had a lot of fun helping them get the show on the road and prepare for the MVP. But unfortunately, because it was a large organization, we were having the usual sort of interdepartmental communication struggles that one tends to have. And we unfortunately discovered very late, 2 weeks before going, delivering the MVP, that someone had greatly misrepresented the volume of data that we would have to handle. So the UI was completely unprepared for this. We had a very naive approach. Initially, we were just using HTML tables. And then we actually finally got permission to connect our application stack up to the production or like production-like data. And it turned out that it just completely drowned our UI. So because of that, we very, very quickly had to iterate on this and come up with a solution that would let us at least be functional for the MVP deadline. So good times. So let's just bring this back down, and I'll just do a small one just to get the idea first. Let me head over to the Kelda virtualized table. Okay, so what's happening now is when I click, 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 what this is doing is every time a state change occurs, it is going and exporting the entirety of the row building operation to a separate thread. So what that means is that while you won't get, it'll still take a while to do such a large calculation once we go ahead and increase the parameters, at least in the meantime, the UI will be responsive. So let's do that. Let's just go ahead and let's do 10,000. And then let's do O of n squared and click, click, click. So you can see that it appears as though it is responsive, and it is, and that's just because the long calculation is happening somewhere else. So the cool thing about this is that we can just scale this. Now you can see that it's actually waiting for each of these rows to be calculated, and then eventually these will come back and fill up. Actually, sorry, I got ahead of myself. What is happening here is that currently I've limited the number of threads in Kelda to 1. So what we can do now is we can go ahead and go to our Kelda, and we can allow it to use 4. It should update. Actually, let me just refresh just in case. And then we'll fetch our rows. Go to O of n squared. Go to 4 tables. So now you can see these are filling in, which is pretty nice. So now I can still interact with all of these, and they're pretty snappy. So let me open up the DevTools here. That, in my defense, that warning does not come from me. That comes from React Virtualized itself, which tells you how old it is at this point. But what you can see here is that when I interact with one of these tables, they're all responsive. And what's really cool is that when I go ahead and fetch these users, you'll actually see that these 4 messages here, finished building rows in Kelda, this is actually coming back. In parallel, right? So if I were to again reduce the number of threads that I have available, let's go to 4. And then let's go to 10,000. Yeah, let's go to 10,000. Well, I think just 5,000 should do as a demonstration. Clear this. So when I fetch, what you should see is that the messages should come in one by one, but maybe something's going wrong. So that's 1. And now a thread has become idle, and the queue should now have popped the next one, and now this one is finished, and now the thread is idle again, and then the next one should resolve, and the next one, and so forth. So you can see that you have quite a lot of control using Kelda over how and when your work gets done. If you want to parallelize it more, you just bump up the thread pool maximum. I'll just do that one more time just to drive it home, because I think it's kind of fun. Despite this being completely useless, I still think it's kind of interesting. So I'll fetch, and now the big chunk of time up front is just calculating the O n squared sort of row data, but then all 4 should come back at the same time. Eventually. Oh, I did 10,000, didn't I? Oh, that was stupid. Sorry, I should have done 5,000. And I guess the final thing to say about that is that if we had already loaded data here, which again, I should have done that differently, but if we had, the tables themselves would continue to be responsive as I was waiting for this big result to be calculated. So I think you get the point. This is going to take a long time to wait for these rows to come back. I accidentally gave it a lot of work to do. So I think we'll leave the demo. Hopefully that was interesting and fun, and hopefully it made you wish never to have to do anything like that ever. So let's revisit what I've said so far. Kelda is good at managing heavy computation for you. It puts it in a place where it doesn't hurt you. It does it with web workers. It's good at managing multiple workers at once. It lets you control how many you want. It's good at falling back to just the main thread if there aren't workers. And it is ultimately limited by the structured clone algorithm, both performance-wise for very large data sets, excuse me, but also in terms of the types that you can pass backwards and forwards. And when it comes to modules and functions, references, which it cannot resolve for you. Kelda, of course, can't directly support browsers without workers, but it won't break. It can't figure out references, big problem. This is why we have to use remote work modules. And of course, it can't solve your design problems for you. So please, I showed you some ways. First of all, of course, always change the UX. Please change the UX. In the case that that's not possible, I showed you some alternatives for the specific example of the huge table. So there's quite a long road that you have to get down before you really have a genuine use case for something like this. Finally, before I wrap up, Kelda is open source. I haven't looked at it in a couple of months because I've been busy, but please give me feedback. I'd be keen to hear if it's working for you or if anybody actually has a use case. I can imagine there might be some good ones that are not in web development. I know, for example, that some web-based editors make heavy use of web workers, VS Code, and so on. So maybe somebody who is in that area, or maybe web-based game development could be interesting. I have only built remote work modules using Webpack. I'd be really curious to see if somebody wants to try it out with one of the other bundling or build tools out there, Parcel, etc. If they're able to do it with that. So I'd love some pull requests for documentation for how to set that up. Thinking about more Dino support, I believe that Dino is going to be using web workers as a first-class citizen to do threading, period. At least that's the last I heard from our colleague in Australia. So that's really cool. And I actually should have shouted out his name. His name is Kit Kelly. So thank you, Kit, for your support. I was thinking about the potential, the order that that work comes back to the main thread being not necessarily in the same order that you requested. So if the order matters to you, we could add order IDs for the work to come back to the main thread so you can sort of sort out which is the newest result. I thought it could be interesting to think about having sort of a coroutine set up between the main thread and worker threads, maybe more long-running worker threads where you could sort of yield values backwards and forwards, kind of like a JavaScript generator. I have no idea if that's useful or if that's just silly. And then finally, type module support is interesting. There's actually web workers do understand or are starting to understand sort of modules as a first-class citizen. This is not widely supported yet, I believe. At least it wasn't the last time that I checked a few months ago. So that could be an interesting thing or interesting part of the spec to directly integrate into the Kelda flow, such that maybe you don't have to deal with the full pain of the remote work module setup. Here are the links to the relevant repos. So the first one is just Kelda itself. It comes with that first test app that I showed you, one with a timer. And then that second one is the demo project with all the tables, which you can also pull down. They're both on my GitHub. And that's it. That's what I got. Thank you so much for listening. Hopefully that was enjoyable. And I'm very happy and grateful to hear any questions. Thank you.
Thanks, Rufus, for doing the talk today. And thanks for the attendees for putting some questions in the chat. There's still some time left to put questions in the chat, but I would start with the first question we received so far. And I will start with a question from Michael. His question was, is the thread pool size the number of threads on the user's computer?
No, not necessarily. The thread, I mean, if you're talking about the thread pool size as the thread pool size that Kelda has, then that is whatever number you configure. The default is 1. But of course, web workers do run on hardware threads, hardware permitting. So ultimately you'll be bounded by the hardware that you have available. Yeah.
Okay, so you could technically put in 1,000 thread pool size 1,000. You could, yeah, nothing's stopping you. Is there some sort of upper limit?
No, not at the moment. But one thing that I did think about, and this is the experimentalness of Kelda showing through, is we could try to put in sort of a safe upper boundary by, there's navigator.hardware concurrency that we could use. to check the browser's opinion of the amount of concurrency that's possible. I think that could be one way to bound it, but that's not something that I've tried.
Okay, thanks.
Okay, next question is from Daniel. I just give you some background information, also a comment, really awesome. Thanks to you, Rufus. And now I'll read through his comment in the chat. I have a personal project on a Raspberry Pi as a kiosk app working with a speech-to-text AI AP working, which is really workload heavy, as you might expect. Therefore, the computation load is handed over to the node process, JavaScript, everything. Do you think it might make sense to make this kind of computation on the client side?
Probably not. I kind of want to try it, just you know, since it's for a personal like a pet project, that could be a fun thing to try. I have to imagine it'll be worse than what you've currently got set up. You know, like browsers aren't really meant for this, but it's interesting.
Okay, Daniel, if you like, you also can unmute yourself and maybe comment here if you would like to get more update from Rufus. If not, there's another comment from Daniel. He was just pointing out, like TensorFlow.js or anything, just to mention, would it be possible?
Potentially. I would need to know more about how TensorFlow.js works. It's on my to-do list, as I'm sure it's on everybody's to-do list these days. But if it's really heavily dependent on having access to certain things that only the main thread has access to, then of course it wouldn't really be possible to export it to a worker. I would have to double check. I'm not sure about that.
Okay, thank you. So Daniel is happy with your answers. Thanks, Rufus.
Thanks.
I had a potential use case. Let's say you have some sort of resource-intensive application, like some sort of optimization problem with a lot of constraints. And you want to make this available to everybody for free. And let's say a lot of users use this application and you don't have much money, and you host this app, let's say on AWS, and it's a very small instance with not much CPU cores. Could you then, for example, say, okay, let me offload all the computation to the front end to save perhaps cost and time in the back end?
Yeah, that's such an interesting question. As you were, I guess, setting up the context, I haven't really, I guess, dared to think too much into this direction, because again, it just feels it's kind of like bending the purpose of the browser as a thing, like way beyond the limit. But I guess that's what all modern web development is anyway. Like none of this stuff was designed for this. But yes, I mean, I think that could be possible in principle, and it sort of changes I guess the model of distributed computing a little bit. You know, like you could even have sort of I guess more sort of, I don't know if like peer-to-peer would be the right term for this, but you could also, I mean, web workers are able to communicate like horizontally between each other. And maybe if you had like a central, I mean, kind of like a MapReduce, you know, like you could probably build some sort of distributed like MapReduce process that requires the clients to have like a Kelda running in their main thread somewhere in the background, but that sort of like, I guess, like farms their workers as additional resources. I think that's technically possible, but I might be getting too excited now. That's super interesting. That's fun.
I had another question. What was my question? Oh, okay, yeah. I've previously done some work with like MATLAB and the parallel pool. And typically when you spawn these new workers, there's a lot of time to basically get the workers ready. So I don't know if you've used MATLAB before, but right when you say okay, bring this pool up, there's some sort of what do you call it, uptime or something? Or I forget what the term is. Sure. Is it the same for Kelda as well?
Yeah, and I mean, that's, again, like Kelda, most of its characteristics ultimately are determined by the fact that it's just a thin veneer over the web API. It tries to make something more fun out of it, but yes, I mean, you'll run into similar problems. You know, web workers do take a while to spin up. Initially, the workers have to be created, and then all of your script has to be parsed. So if it's a largish chunk of JavaScript, like you'll notice the hit on the first time that you spin the workers up. I actually, the last time I gave this talk internally at our frontend community, somebody had told me that they had previously used web workers on a project where, for some reason, somebody had built a complete email client on JavaScript, from like the networking layer all the way up to the email protocol parsing stuff, MIME parsing, the whole thing, all JavaScript. It was slow, of course, and so they started using web workers to help, and they were noticing a significant, like, I guess, additional payment of time that they were making every time they started up a new worker. That's interesting. I have not, like, since my, the work that I've been working with is kind of toy, or they're all toy problems. It's not like the actual scripts that I'm passing to my workers aren't huge. So I haven't run into that problem specifically, but I do think that we could get around that, so that you only have to pay that expense once up front. At the moment, Kelda is really wasteful. It like starts and kills workers every time you order work. You know, we could take a different approach where at the beginning, when you load the document, that Kelda would just create 4 workers and just reserve them forever.
Yeah, you can set some sort of idle time. If it's idle for 20, 30 minutes, then you kill them.
Yeah, sure. That's a good idea. Yeah.
Last question for feedback. Should we send that to your email, like about the presentation?
Sure, I would love that. I'd really appreciate that. That'd be very kind. And yeah,
Okay.
email is great. And then, for feedback about Kelda itself, if you'd like to try it out, of course, PRs are always welcome. And then the communication can just go over the repo itself.
Okay. Cool.
Thanks, Michael.
Okay, so far we have no more questions in the chat. Then a big thank you from Alu for the talk. And I guess for today, that's it. Thank you so much for joining.
Thank you for having me. I really appreciate it. See you in Berlin soon.